Hello and welcome to this video series from the National AGI Hub. My name is Shishir Nagaraja, Professor of Cybersecurity at the UK National AGI Hub and Newcastle University. In this video series, we will show you about the projects we've been doing on swap platforms, which is platforms with limited by size, weight and power constraints. Our goal is to analyze federated learning security threats and attacks that can take place on these swap platforms with a view of both audio inference and image inference. So we're looking at intelligence layer attacks on audio and on video. Let's get started then. So this is just the content of what you're going to actually be seeing. So just as an introduction to what we will have coming in the following slides, the first sub-project we'll be talking about is inference model attacks on image classification. So this is the application of conventional attacks such as gradient descent among other attacks and label flipping attacks carried out on the Flower framework and using multiple clients and a server. And the server is fixed and it's all connected using TLS, so the standard security settings are all turned on. And we'll show you what the effectiveness of the attacks are. The next sub-video we'll be showing is on leader election attacks on federated learning. So in the context of audio inference models applied to the use case of speech recognition. So this is very important because a lot of swap platforms carry microphones, and the objective is to record audio and then use the audio that's recorded and pass them through inference engines to automatically convert them into whatever speech has been recognized or whatever bird calls have been recognized. So in this video, we'll be showing you a series of attacks on them. Initially just one focused on federated learning, but then also another two on conventional non-federated learning contexts. Then we'll show you a sub-project on detecting drones versus detecting birds using a federated learning setting. So this is quite important because from a drone's perspective, which ones are birds and which ones are not birds are flying objects. Both are flying objects is kind of important to know. We'll show this within a vertical federated learning setting. Next, we shall look at denial of service attacks. So this is an important class of attacks within federated learning, as it's very common that parts of the federated learning network come under denial of service attack, and therefore they will not be able to fulfill the learning needs of the network as a whole, not being able to supply the learned information into a compressed model. So this can take place at multiple venues, can take place at the client, can take place at the server, we show how these pan out and what the effect is on federated learning. Next up will be wireless jamming. So this is at the physical layer where we show you how the Wi-Fi network module can be jammed and how that interacts with federated learning, right? So that's what we show you. So this we show you on a small test bed that we have developed especially for the purpose on Raspberry Pis. After that, we have a federated learning we have developed a federated learning attack simulation network. And within this attack simulation network, we're showing the various ways by which federated learning attacks at the network level can manifest. So they can manifest in the form of delays to messages, they can manifest in the form of missing messages, or they can manifest in the form of the denial of service attack. There's many of them. So how do these at various grades and at various levels of intensities leads to adverse outcomes is what this demo will show. Following that, we have two more demos, and these are on audio intelligence layer. So they are injection attacks on a audio model, and the goal is to show that even if you know you've got a swap platform with a microphone that's on and is not being actually used, but the microphone is on, then audio can be injected into it, and the supervisor might think that that's merely a bit of wind noise or something like that, whereas actually it's command injection into the device. So in the case of a drone, for example, a drone that's parked may receive a audio command which asks it to do something, and the commander or the controller might think that's just wind noise, but actually it's not. It's something much more sinister than that. So we demo these attacks and implement and show you how these attacks might work in this one. Finally, we will talk about the application of all the conventional model attacks like FGSM, the PGD, and all the variants on audio classification. And this is to do with keyword detection. So often you might fly a drone to a location and listen to what's going on there. You listen to conversation, you listen to you know, things as a way of capturing large amounts of information and automatically converting them into text. What we show is that that automated system can be bypassed quite easily, and we do this using the Roblox classifier, which is a well-known classifier used for the purpose of detecting swear words. And we show that with clever changes in the audio, the swear word detection system can be completely bypassed. You can replace swear words with command words or any other words. So if you're out there looking for a certain word in recorded video, and that's the job of the audio automated inference system, it can fail to do that to different levels of criticality. So I hope you enjoyed this video series, and I will come back to you with more in the future. Thank you very much.